LEDs have stormed the lighting market over the last 15 years and changed the very way that we see. Is the next phase of LED technology just a continued push for the lowest cost and good enough? Or are there still innovations and advances that could open up entirely new applications for how engineers use these products? Since the very invention of the light bulb, I'm not sure there's been a more disruptive technology for the very way that we see the world around us than solid state lighting. I know one of my initial designs as a design engineer, probably around 2002, 2003, was working with high brightness LEDs for the first time on an outdoor illumination system where I was taking an array of LEDs, trying to illuminate a small area with a solar panel, a battery, and trying to deal with getting enough light output, dealing with the hot spots of where the light was going, making sure that I wasn't going to end up in a situation where everything was overheating in these LEDs. Today, things have changed so much. The number of lumens per watt we can get out of an LED has risen dramatically. The amount of thermal issues that we have as we drive that light through our LEDs also really, really down. And then the cost of LEDs themselves have dropped enormously and made them much more practical for so many different applications. But is that it for solid state lighting? Are they doomed to just become another commodity where we're constantly racing towards the bottom lowest cost price, all at the detriment to new innovations? Today, I have the privilege of speaking with Erik Swenson, who's the Vice President of Nichia Americas, and has spent a lot of time looking at this LED technology and where we can take it, how we continue to innovate with it as engineers, and what new markets could possibly be entered with this technology. Erik, thanks so much for joining me today. So, as someone who got to design with high brightness LEDs, in the application that I mentioned, and kind of had to deal with a lot of the pains with that technology before it, crossed the chasm and became fully adopted, I've really been fascinated over the last 20 years of where this technology has gone and the new things that are really practical and available to us as engineers. What are the innovations that we've seen over the last 10 years? What's the reason that we've kind of driven this way? And what are some of the things that we've done to accomplish what we have with LED technology to really replace the incandescent light bulb almost entirely?
No, first off, Todd, thank you. Thanks for having me. It's awesome to be here. I've been watching a bunch of the episodes. It's fun to watch. It's fun to see the clear in the conversations. I've been fortunate to be with Nichia about 15 years now and really see the growth and the adoption of the technology, like you said. And at the risk of sounding like my dad back in the day, we used to talk about LEDs that were 30 lumens per watt. And man, if we could hit 100 lumens per watt, game over, right? And we've kind of blown past that a little bit, which is cool, it's fun. But when you talk about the innovation of solid state lighting, it really dates back to Nichia's first innovation. We're the inventors of the high brightness blue LED in 1993. And just last year, we celebrated our 25th anniversary of Nichia's invention of the white LED in 96. So that's it, right? That changed our company, that changed the world, and really was game on for the technology at that point. And over the years, obviously, there's been lots of advancements in epi, in phosphors, in packaging technology, but ultimately we knew the goal. We knew the goal from early on, right? And as you said, there in the lighting industry, we were looking at halogen. We were looking at, incandescent. We were looking at halogen. One of the end goals, replace fluorescent, right? We knew the path. We just needed to accomplish it. So while I always like to focus on lighting, really a lot of the innovations that enabled us in those types of applications stemmed from LCD backlighting. And a lot of the technology and advancements that came from LCD backlighting drove the scale, drove the volume. One example is the 3030 package. That really kind of stemmed from technology and LCD backlighting that really enabled us to attack lighting. Circa 2010 timeframe, and we talk about those efficacies in attacking incandescent and fluorescent, et cetera, and we blew past those, right? And that really drove us to where we are today.
Yeah, and it's been exciting to watch. I think I remember, because I having designed with LEDs, I was excited the first time I walked into Home Depot and saw, bulb replacements that were
Yeah.
LED based. And, it doesn't seem like that long ago, the first time I saw that on the store shelves. But I remember thinking to myself, this is cool. It's going to be a neat little niche market. And,
Yeah.
maybe 20, 30 years from now, it'll be a bigger space. But, it's probably going to take a while before that's really, really formally adopted by everybody. But now you go to Home Depot or Lowe's or wherever, and it's very tough to find something that isn't LED based.
Yeah.
And it just happened, the adoption to me happened so rapidly. And I think it's a big part of that is because of all the innovations that you mentioned there.
It's funny
But
you referenced that. I got in trouble so many times with my wife at Home Depot or Lowe's because I would, hey, I'm just going to run over here and look at the LED stuff and
right.
see what people have to say. Like, no, Eric, come on, it's light bulbs. No, it's more. It's cool. This is
Yeah.
exciting.
Yeah, right, right. If you're like me, we have a lot of great LED suppliers on our line card that we represented, and there were a couple that we didn't represent. They seem to be taking the early market share, and I always used to be like, those jerks.
Always
I'm
fun.
not buying that one. I'm going to
Always
go buy this one over
exactly. Yes.
here. We get those little loyalties.
Yes.
They're
Competition.
kind of fun and make it all fun. So. But when we talk processors, we're talking LEDs here, but forever, I think, we all know when we talk processors, we talk about Moore's law,
Yeah.
right? And the constant miniaturization of the transistor, and that's going to, constantly we're going to get more and more computing power on a steady cadence. And so far, Moore's law has been true. Is the same thing true in the solid state lighting space when it comes to lumens per watt? Because when you look at the growth curves of the lumens per watt over the course of the last 10 years, it is almost a logarithmic curve where it's just got that constant brighter and brighter and brighter, capabilities with less and less energy. Is that kind of where we are? Is that the only place in innovation to continue to pursue when we're talking about solid state lighting, or are there other pursuits do you believe LED engineers should be chasing?
Sure, sure. No, I mean, that's what we're talking about, right? And that's what I've been talking about in the industry for a while. And you reference Moore's Law. Solid state lighting has Heitz's Law, which is kind of the counterpart to it, which
Yeah,
when that first got brought up, it was the concept that, okay, that your cost of light is going to decrease 10x every decade, and your light output will increase about 20x over a decade as well. And Roland Heights also predicted that LEDs would surpass 200 lumens per watt by 2020, which at the time was like, holy cow. Again, remember I
yeah,
referenced if we
yeah,
could hit 100 lumens per watt. He was pretty dang close. In fact, probably a little conservative because we hit 200 lumens per watt before 2020. So it's it definitely is exciting. It's cool to see how that applies. The talk of efficacy, that has been what LED adoption was. It was mostly all focused around energy savings, which was great and obvious. But we also talked a lot about replacing additional technology, lamp replacements, replacing the lamps, replacing. And that was the focus of kind of what I call phase one of LED adoption, was energy savings and replacing what we've done. And I don't want to belittle energy savings by any means. That was huge. That was a game changer for all of us for generations. But also kind of being an armchair quarterback, looking back over the last 15 years, did we sell the LED technology short by doing it the way we did it and simply just replacing lamps in that
yeah.
same form factor and not really taking advantage of what we can do, especially now that we've achieved the energy saving story. And that kind of is where we move into phase two, if you will, and what can solid state lighting do? And we have to think differently. We're kind of at another crossing the chasm point here of which path do we want to pursue? And I gave a talk late last year at the IEEE Photonics annual conference about this and kind of solid state lighting being at a crossroads. And I gave a reference to phones. For about 40 years, from the 50s to the 90s, phone technology was meant to do one thing. It was meant to call somebody, right? And you had technology improvements year over year. Phones got smaller. You had a cordless phone, which was really cool. And then, man, we had a wireless phone, cell phone, pretty
Yep,
amazing.
yep.
But still, was meant to call people. And then, okay, Nichia's inventions in the 90s allowed us to have an LCD screen, a color LCD screen, but again, still calling people. And it wasn't until phones started to utilize the technologies around them and the tools in their toolbox to do other things with phones beyond just calling people. Heck, now cell phones, I think calling people is probably the last thing we use our cell phones for, right? We do them for everything else. Oh, by the way, yeah, we can call somebody. So
Right, right.
I think we need to apply that to lighting now as well, and think differently. And lighting can be so much more than just flipping a switch and lighting an area, right? We can do so much more and pursue so much more. I really do hope that we don't take that path of just low cost, good enough. We know if that's the path we pursue, we know who's going to win that game. Low cost, low quality, right? And good enough. Also in that talk, I made a reference to a quote from Jerry Rice, and he said, "The enemy of the best is good. If you're always settling for good, you're never going to be the best." And I think that really applies to where we're at right now. And in a lot of the talks I'm doing, challenging designers and specifiers and municipalities, anyone touching lighting, to understand the tools that are in your toolbox and the things you can do with lighting now that you never were able to do before. Again, a cell phone, the things you can do with a cell phone are so much more than making a phone call. So when I think about that and think about what are those tools and toolboxes and different applications that we can pursue, I challenge everyone to know that, okay, we can raise the bar for quality of light. We can do more in schools, in offices with higher CRIs, not sacrificing the efficacy anymore to achieve 90 plus CRI. Why does indoor lighting need to be 80 CRI? It can be 90 CRI now. Why does outdoor need to be 70? No, it can be 80. Why do we still need to use HPS lamps when you can do it with LED now with higher CRI and better safety from them? We talk about human-centric lighting. That's a new technology that we can utilize light in different ways to improve our health and use light to energize us when we need to or calm us when we need to. Tune colors, whether that's in my home to whatever color I want, or in the office throughout the day to have different types of colors, and ultimately design buildings in a different way. If we want to get real holistic and step back and say, man, we can do so much more. We can change how we design our buildings if we think about lighting early on in the process versus the last thing. Like, oh shoot, yeah, we got to put lighting in the building. Let's right. In there, right? In the same form factor that we always have. No, LEDs are tiny. We can do things differently. We can do them in different form factors. Obviously, we're a Japanese company. They're doing some really cool things in Japan where they're able to squeak out a couple more floors in a building by using different lighting and shrinking the height between the floors in the building. That concept is cool because you're thinking about lighting early on. So that's that path too. That's the other path of not good enough, is taking advantage of these tools. And to the engineers, this is the fun stuff, right? We're not just populating an LED on a circuit board and doing Ohm's law. That's the boring stuff. Now we're talking about tech. Now we're doing some really cool stuff. So it's just a matter of knowing what tools you have in your toolbox, and those tools are becoming more and more, right? So,
absolutely incredible. And those are the things that I don't think, you consider, is how not only is, obviously as electrical engineers, this has a huge impact on the way that we design, but it's impacting the way that civil engineers and architects and many other professions should be looking at how they design as well. And that's incredibly exciting. And then I think, some of the other side that we've seen be a lot of adoption in lately has been using solid state technology for UVC applications to clean air, clean water, and cleanse the world around us as well. And then I'd never even considered the concept of being able to use different temperatures of light to possibly have an impact on energizing us or our psychology, our mood. That's fascinating as well.
Another one I didn't touch on though as well that to me is really mind-blowing is Li-Fi. The ability to use light to communicate data and share data. LEDs operate at such a high frequency and can turn on and off so quickly. That is awesome. right?
Yeah.
Talk about using light in a different manner, in a different way.
Right.
So.
Right. No, absolutely incredible. And these are the kind of applications that I think reinvigorate all the excitement I had 15 years ago about this
Yes.
technology,
Yes.
and are going to be fun to watch where those can go over time. But, what other technologies, when I look at some of the other technologies that are often associated with lighting, we talk wireless technology and communication, not just, in a Li-Fi application, that kind of thing, but also just to be able to communicate and not have to have a wire harness running all through the ceilings, but have lights that are just have wireless connectivity to your phones. You can turn them on and off. Communications technology, so you're connected to the cloud, things along those lines. Are there other electrical engineering technologies that need to continue to advance, or that we need to be working on to allow some of those paths and applications to open up for solid state lighting?
I think that's one of the big challenges we face right now, of going down that path. Is it is no longer just putting an electronic component on a circuit board and supplying some power to it. There's a
Yeah.
lot more complexity to it. And again, whether it's an electrical engineer, optical engineer, thermal mechanical engineer, civil engineer, like you said, this can apply to so many different people. And I think those other areas are where you're seeing a lot of manufacturers and a lot of people pay more attention to. So you think about controls. That is a key element of a lot of these new technologies. Not simply just turning the light on or off, but just controlling the light a lot more in different ways, different manners. Um, when we talk about improved light output, with that comes hotter temperatures. You touched on it right at the beginning. So being able to manage the thermals a lot differently and a lot better. Coupled with the controls is software. You're seeing a lot more software engineers enter the
Yeah.
lighting space, and companies being startup companies, or even the larger big name brands having divisions now for software that they never did before, which is really exciting. And then also just optics. I said optical engineers, but being able to put the light where you want it. I say it all the
Yeah.
time. Solid state lighting enables us to use the type of light that we want, when we want it, and where we want it. And when I say that, I have a 7-year-old daughter, so we've watched a lot of Disney zombies. It sounds kind of like a cheerleader comment,
Yeah.
but
Right.
give me the
Right.
type of light I want, where I want it, when I want it, right? We have the ability to do that now, which is cool. But there
Absolutely.
are challenges and other areas, to your point, that still need to be improved.
Yeah, yeah, and I think those innovations are being made there as well.
Yep.
As the entire world needs more and more semiconductors for everything that we do, we get more connected, and expectations of the end user are that things get, more, just the world operates around me at my whim. If I can think it, the world around me should change to be it. So I think that'll be exciting to see how that occurs as well.
Yeah.
So now, as far as Nichia itself, what are the things that you as a company are doing, and what do you think it is that differentiates you from other LED suppliers out there? How are you guys making sure that you're not becoming a commodity, chasing after that lowest price, or the highest efficiency or the best availability? What makes you different?
There's a lot. Nichia is a unique company in many
Yeah,
areas, but we are fortunate to be the inventor of the technology. There's a lot that holds
yeah,
behind that. We are a leader. We are the world's largest LED manufacturer by far, so that helps. We are a privately held company, which is pretty amazing to think of the size and scale. Uh, Kind of like you guys, to
kind
be
of like you.
privately held,
Yeah,
and there's so many benefits that come with that you can take and make long-term decisions that are right and make sense and are logical, and not get caught up in short-term trends or short-term challenges that maybe don't fit your mold or don't fit your strategy. So that helps continue to differentiate. The other piece is we are number one or number two in really all of the key segments where LEDs are used, whether that's LCD backlighting or automotive, general lighting, video display, and we're really balanced across those segments as well. So that balance gives us, and the diversity gives us stability. And let's face it, we're at a time right now where there's so much instability in the
absolutely.
world, in manufacturers. So to have that comfort to know that Nichia is healthy and stable and diversified and playing all our cards the right way, that's a huge differentiator. Now, those are all kind of surface things, but to me, the most awesome part of Nichia is the fundamental piece of who we are as a company. We're fundamentally a material science company. We were founded in '56 as a specialty chemical company. We were the world's largest phosphor manufacturer. And then, we stumbled upon LEDs 40 years into our existence, which kind of was a nice little invention for all of us. But at the root of who the company is, we're technical, engineering-driven company. Even our salespeople, myself included, we're engineers by degree. And I joke all the time that as large as we are, over 9,300 employees now, it wasn't until just recently that we even had a marketing department. So it's all the time and energy and effort and resources are invested into technologies and the people and the infrastructure, and let the products speak for themselves. And that has been, fortunately, a very successful model over the years, and just really enabling our engineers in Japan to lead the company, and our manufacturing capabilities to lead the company and invest in Japan. And I think that too is another differentiating fact, that we do all our manufacturing in Japan, minus some of our lamp type LEDs for the display market, but everything is in Japan. And again, that long-term thinking, we're not outsourcing any of our manufacturing. We're not going to low-cost countries and sacrificing elements of manufacturing or quality. We're keeping everything in-house, keeping everything in Japan. And hopefully our customers really continue to see us as an innovator, as a leader, and really pushing the envelope on technology and manufacturing capabilities. To me, everything else comes from that at the root.
Absolutely. And amazing amount of, engineering talent that you guys have. And with all that technology and engineering expertise that you've obviously developed over that time, and I think we kind of touched on some of it already, but what are the areas and applications that you really are investing in today from an R&D perspective to continue to get be ahead of the game and be a part of the solution for new applications where solid state technology is going tomorrow?
Sure. No, that's the exciting piece that we're all staying on the edge of our seat for. I think in the lighting space, I touched on it earlier, human-centric lighting to me is really cool and has benefits far beyond just lighting up a room. Again, there are technologies out there. We have our Dynasolis solution, our Vitasolis solution that support this. There's plenty of research and science behind it, whether it's internal from Nichia or third party or through academia. There's lots of science that supports human-centric lighting and the benefits from it. I hope that can get adopted. We have challenges, obviously, commercially, economically, of the return on investment for it, but just again, holistically, that makes plenty of sense, and we're going to continue to invest in that space. I touched on it again earlier, color tuning and color selecting. So recently Nichia released a 2-in-1 single LED that can do multiple colors out of a single light emitting surface, LES. That was a first of its kind, and that enables color tuning out of a single LED, which is going to simplify your electrical design, simplify your optical design. And immediately when I say color tuning, I think, okay, in a room, I can change my color actively. Yeah, that's cool. There's spaces for that. Maybe it's gimmicky, maybe it's niche, but you can do it over day and have that be an element of human-centric lighting if you want. But another piece, the color selectability, to me, there's huge opportunities there, because if you think of in a warehouse, how many SKUs you have of different fixtures. I have a 3,000 Kelvin fixture. I have a 4,000 Kelvin fixture. I have a 5,000 Kelvin fixture. I have to keep all these on hand. Well, imagine just having one part number, and you get your order, you select your color, you ship that same product over and over again, or you install, select the color at the time of install, but again, one part number. That type of technology enables that. Again, it's a different way of thinking, because an engineer designing a fixture isn't sitting down thinking about my operational savings that I can get by SKU management. But hey, as a team, work together and think differently about how you can take advantage of solid state lighting. You touched on earlier UVC, germicidal UV. I've spent a lot of time the past 2 years talking about germicidal UV and where UVC is going. To me, this is just talk about re-energizing, because it's circa 2005 all over again in terms of efficacy, right? And again, playing armchair quarterback, let's not just replace a light bulb. Let's not just replace mercury vapor lamps in germicidal UV. We can do so much more. And in terms of efficiency there, again, we're circa 2005. That hockey stick's coming. That's coming quick. And we know the levers to pull. We know how to do it. We've done it before. We have all those lessons learned. So that's going to be a fun ride the next 5 years. In automotive, Nichia continues to lead the way in technology, especially in exterior, as we enter the game of adaptive beam control. That's going to be really fun, and looking forward to new innovations there. Another huge growth market for Nichia is laser diodes. It's a space of technology that, I hate to use the pun, but we're light years ahead of the rest of the pack in terms of laser diode performance and technology. And the amount of applications that's opening up is really exciting. Today it's projectors. That's a good application, but exterior of a vehicle and a lot of industrial applications can come about. Maybe even lighting, right? You think about what you can do optically with a beam of light is pretty exciting. So really, again, no matter what the application is, it boils down to us thinking differently and utilizing the right type of light at the right time where we want it. I keep going back to that.
Yeah, no question. And absolutely amazing. It's going to be exciting to watch how we continue to innovate in this area. I think it does feel like we're still, at the cusp of something. The way that we look at all of the way the world around us and illuminate the things around us. I think there's a lot of new advances and technology changes we're going to see. It's going to be fun to be part of. So very excited about that. So Erik, thanks so much for joining me today. Thanks for sharing your insights, your expertise in this area. It's absolutely fascinating. And I'll tell you, it really does reinvigorate my passion for LEDs and where things are going. So I can't thank you enough for that. Thanks to all of you for joining us on The Current today in this episode. I hope you've gotten as much out of this conversation as I have. If you have questions on your lighting applications, on LEDs, on Nichia that we can help with, we absolutely would love to be part of that. We'd love to have future electronics engineering team assist with that, make introductions to the personnel at Nichia and assist in those designs. Please feel free to reach out to us at shapingthefuture@futureelectronics.com. Again, shapingthefuture@futureelectronics.com. And we'd love to help you with all of your embedded design needs. Erik, thanks again so much. Thanks to all of you for joining us today. And we'll look forward to talking to you soon.